Here you've got a question about a time of flight calculation. We've been asked to work out the mass of a BR79 plus iron in kilograms, and then we've been asked to work out the time taken for a BR81 plus iron to travel through a flight tube. Now, we've been given some important information to answer this question. We've been told that the ions are accelerated to the same kinetic energy. The flight tube that both ions go through is 0.95 metres long, and the BR79 plus ions took 6.69 times 10 to the minus 4 seconds to travel through the flight tube. First thing we're going to do is what's highlighted in yellow. We're going to work out the mass in kilograms of one BR79 plus iron. Now this 79, remember, is the mass in grams of 1 mole of BR79 plus ions. We need to work out the mass of one individual ion in kilograms, and we do it like this. We firstly convert the grams value into kilograms by timesing it by 10 to the minus 3. Then we divide that by Avogadro's constant to work out the mass of one individual ion. That should give me 1.312 times 10 to the minus 25 kilograms. So that's the first bit of the question done, which should be relatively straightforward. The next part of the question then asked me to work out the time taken for the BR81 plus ion to travel through a particular flight tube. Now the time is equal to distance over velocity. Now the distance part is fine. We've got the distance, it's being given here as 0.95. But the velocity, we do not know. How do we work out velocity? Well, velocity is equal to square root of 2ke over m. Now the mass of the BR81 plus ion can be easily worked out in the same way I've worked out the mass of the BR79 plus ion. But what I need to work out is the kinetic energy. It tells me though the kinetic energy is the same for both ions, and there is a way I can work out the kinetic energy for the BR79 plus ion. First thing I need to do is work out the velocity of that ion, and velocity is distance over time. Distance is 0.950 divided by the time, which is given in the question at 6.69 times 10 to the minus 4. Once I do that, I get an answer of 1,420 metres per second. So that's the velocity of the BR79 plus ion. The kinetic energy then is equal to half mass times velocity squared. So the kinetic energy then is equal to half times the mass, which is 1.312 times 10 to the minus 25 times 1,420 squared. That gives me a kinetic energy of 1.323 times 10 to the power minus 19 joules. So I've now got my kinetic energy. Now we can go back and have a look at this. Now I've got my kinetic energy, I can work out my mass, I can work out the velocity. Once I've got velocity, I've been given the distance, I can work out time. So the next step is to calculate the velocity of the BR81 plus ion. And then velocity is equal to square root of 2ke over m. This m, well, we can work that out in the same way we worked out the mass for the bromine 79 ion is 81 times 10 to minus 3 divided by Avogadro's constant. That gives me an answer of 1.345 times 10 to the minus 25 kilograms. So my velocity then is equal to 2 times the kinetic energy, which is 1.323 times 10 to the minus 19, divided by 1.345 times 10 to the minus 25. And that then gives me an answer of 1,402.6 metres per second. So if I now want to work out time, then time is equal to distance over velocity. Well, the distance is 0.950, and that's divided by the velocity, which is, we just worked it out as 1402.6, and that gives me the time value of 6.77 times 10 to the minus 4 seconds. And that answer should make sense. It should be very similar to the answer given here, but because this iron is lighter, it will take less time to travel through the flight tube. So the time for the BR81 iron to travel through the flight tube is a little bit longer. There is another method to working this out, and that is we can, because we assume that the kinetic energy both ions are given is the same, then if this is my, say, BR79 plus iron, this is my BR81 plus iron, the kinetic energy is the same, so half mv squared will equal half mv squared. Now I'm going to times both by 2, that'll give me mv squared equals mv squared. Now, velocity is equal to distance over time. That gives me the following. Now, the distance is a constant, so that can cancel. And that gives me the following, that m over t squared equals m over t squared. Now, this m value here, we can simply use the masses 79 and 81. There's no need for me to convert this into the mass of one iron in kilograms, because whatever I'm doing here, I'm also doing here. So what I can get then is 79 divided by this time, and now we know this time, it's been given here. Time taken for the BR79 iron to travel through the flight tube, that's 6.69 times 10 to the minus 4. That therefore is equal to 81 over this t squared value. I'll just be aware that this is actually squared there, sorry. Now, I need then to rearrange this to get t. So t then is equal, now if we rearrange this value, then t is going to be equal to the square root of 81 times 6.69 times 10 to the minus 4 squared divided by 79. And when you do this calculation, you should get exactly the same answer, 6.77 times 10 to the minus 4 seconds. Oops, it's just seconds. Now, either of these methods is absolutely fine. Either of them methods, as you can see, will give you the same answer. Which method you use is just a matter of personal preference.